Section 1.5, Solving Other Types of Equations. First, we'll look at radical equations. Step 1, isolate the radical. Step 2, square both sides of the equation. Step 3, check your answers. Sometimes this will generate extraneous solutions. In our first example, we need to start by isolating the square root. Add 2 to both sides. Square root of 12t plus 4 is equal to 4. After you isolate the radical, you want to undo the radical by squaring it. If you do that on the left, we'll do that on the right side as well. Here we get 12t plus 4, the radical goes away, equals 16. Subtract 4 on both sides. 12t is equal to 12. Divide by 12, and t is 1. Now, since we raised both sides to an even power, we do want to check our answer. If you're using an even power, sometimes it can generate extraneous solutions. To check, we can plug our answer, what we think is the answer, into the equation. So we're going to replace t with 1 and ask, is this equal to 2? Negative 2 plus the square root of 16 is 2. Negative 2 plus 4 is 2. 2 equals 2 is a true statement, so we know our answer 1 is correct. In the next example, we'll start by isolating the radical. Add 5 to both sides. Once we isolate the radical, we're going to raise both sides to the power of the index. In this case, we're going to cube both sides. Instead of square it, we want to cube it because the index is 3. Cubing a cubed root will eliminate the radical. We're left with 1 minus 2x equals 5 cubed is 125. Subtract 1 on both sides. Divide by negative 2, and we get negative 62. Here we will not generate extraneous solutions because we raised both sides to an odd power. It's probably a good idea to check, but this will not generate extraneous solutions. The only time you'll potentially generate extraneous solutions is when you raise both sides of the equation to an even power. In the next example, we need to work through this process twice since there are 2 radicals. First, we'll isolate the radical on the left. So we need to subtract the square root of x plus 2 to both sides. Square both sides. Doing so will eliminate the square root on the left side. Now on the right side, notice we have a binomial that is being squared. To make our algebra a little bit easier, let's recall the shortcut to square a binomial. A plus b squared is the same thing as squaring the first, doubling the product of a and b, and then squaring the last piece. So when we come over to this binomial, we'll square the 1, double the product of 1 and the radical, and then squaring the last piece, squaring the radical, will simply eliminate the radical. From here we can combine like terms on the right side. They'll give us 3 plus x minus 2, square roots of x plus 2. Now we need to work on isolating the radical. So subtract 3 on both sides. Subtract x on both sides. We're left with 2x plus 4 is equal to negative 2 square root of x plus 2. At this point, the square root is not completely by itself because we have this negative 2. If you want to, we can divide both sides by -2 and completely isolate the radical, but we don't technically need to. With this product here, we can go ahead and square both sides, and this is going to eliminate a little bit of the work that we need to do. Again, on the left we have a binomial squared, so let's use the shortcut. Square the first, double the product, and square the last. On the right side, we're going to square the -2, and squaring the radical will eliminate the radical. Simplify on the right side. So we'll distribute the 4x, and finally set it equal to 0. Subtract 4x, subtract the 8, and we have a quadratic that's set equal to 0. Notice all three terms are divisible by 4, so we can divide everything by 4 and make our quadratic a little bit easier to solve. From here, factor. Two numbers that multiply to 2 and add to 3 are 1 and 2. Set each of those factors equal to 0 and solve. X is equal to -1 and x is equal to -2. Now notice we squared both sides. That means we can sometimes get extraneous answers. So we need to check this. And whenever you check something, you always want to go back to the original equation. So let's check -1. Let's plug in -1 into our original equation. Square root of 3 times -1 plus 7 plus the square root of -1 plus 2. We're asking, is that equal to 1? First we get -3 plus 7 is 4, square root of 4, plus the square root of 1. Is that equal to 1? 2 plus 1 is not equal to 1. So it looks like -1 does not work. Let's check the other one. So let's check -2. 3 times -2 plus 7 plus -2 plus 2. We're asking, is that equal to 1? First we get the square root of 1 plus 0. Is that equal to 1? 1 equals 1. Looks like -2 is the only one that works. -1 is extraneous.